Electricity is a form of energy resulting from the movement of charged particles, typically electrons. At its most basic level, electricity involves electrons, which are negatively charged particles found in atoms. Let's understand electric charge, the fundamental property that makes electricity possible. There are two types of electric charge, positive and negative. Opposite charges attract each other, while like charges repel. Now let's explore electric current, the flow of electrons through a conductor. When electrons move through a material like a metal wire, we call this flow of charge an electric current. Materials can be classified as either conductors or insulators based on how easily electrons can flow through them. Conductors, like metals, allow electrons to move freely. Insulators, like rubber, restrict electron movement. Voltage is the electrical potential difference that drives current through a circuit. We can understand voltage and current by comparing it to water in pipes. Water pressure is like voltage, pushing water through the pipes. When we connect a battery to a circuit, the voltage from the battery drives electrons through the wire, creating current flow. Let's summarize the key concepts of electricity we've covered. Electric charge forms the foundation, with positive and negative charges that interact. Electric current is the flow of electrons through conductors. Materials can be conductors or insulators based on electron mobility. And voltage is the driving force that creates current in circuits. We experience electrical phenomena every day in various forms. Let's first look at static electricity. Static electricity occurs when electrons transfer between materials, creating an imbalance of charge. A common example is rubbing a balloon on hair. The friction causes electrons to move from the hair to the balloon. The balloon becomes negatively charged, while the hair becomes positively charged, causing attraction. Lightning is a dramatic example of electricity in nature. Charges build up between clouds and the ground, creating an electric potential difference. When the electric field becomes strong enough, a rapid discharge occurs, which we see as lightning. Now let's look at how electricity powers our homes and daily life. Electricity is generated at power plants, often by converting mechanical energy into electrical energy. It's then transmitted at high voltage through power lines and transmission towers over long distances. Finally, it arrives at our homes, where it's converted to different forms of energy. In our homes, electrical energy is converted into light in lamps, heat in stoves, and motion in fans and motors. Electricity is the foundation of modern technology, powering devices that have transformed our lives. Our smartphones, computers, and increasingly our vehicles rely on electricity to function. From communication to transportation and entertainment, electrical phenomena are at the core of modern life.